Cheese.
Cheese. Okay, recording. Hello, Amel, Asma, Aya, Ayub. What was the trick to keep this floating? Think like this. Yeah. Bilin, Inamon, Ingasi, Harp, Jonja, Joel, Mariam, Minatalla, Coach, Mika, Mina Midhat, Nemo, Said, Sabah, Set, Shadow, Eduak, and Omar. So today we probably gonna need some water, so please bring water with you because this gonna be a fun LeetCode to solve. Let's jump to the first one. Tree summarize. Okay, let's go through this. So what they're saying is, given an integer array nums, return all the triple nums e and nums g, num k. Okay, don't cheat, don't see there, such that e and doesn't equal g, e doesn't equal k, and g doesn't equal k, and nums plus e, or nums e and nums j, nums k equals 0. Nemo, you have mic open. If you can mute it, please. So notice that solution set must okay, feel free to open mic if you want to talk. Just sometime your mic open can have background noise. Okay, so let me zoom like this. So given an integer array nums, okay, here is it, nums, return all the triplet nums e, nums g, nums k. Okay, we can see their return. There is 3 elements, num a, j, and k, such that e doesn't equal j, e doesn't equal k, and g doesn't equal k. And nums e and g and k, so the value of them is 0. So there is three number in this array that if we did the sum of them, it's gonna be 0, and the index e and the index g and k, they should not have the same numbers. Let's take it to the dictionary and try to understand it. So in this case we have in this case we have -1, 0, 1, 2, -1, -4. So we have this element -1 right here, -1 right here, and 2. This gives us 0, and we have the other one, -1, 0, 1. So we have this -1 with this 0 with this 1. They give us also 0. The distinct triplets are -1, 0, 1, -1, -1, 2. Notice that the order of the output and the order of the triplet does not matter. So the order doesn't matter, but this is like unique solution. One thing they said is like, for example, if they use -1 here, I can't use it again. Right? That's what they say. So E doesn't equal G, E doesn't equal K, and G doesn't equal K. No. So
like all of them must not be equal to each other? And in that case, why would we have -1, -1? These are the same.
Okay. Can you repeat?
I think. Okay.
Like they want G and K and the other one to be different from each other, right? All of them.
Yeah. So it's not same elements. Oh, I see. So it's not the same element. E element and G and K are different, like different elements from here. So I can't use -1 here and same time put it in G and K. So, for example, you did use num0 here. You can't use num0 here again.
I think he made like the index.
The index, okay. I thought the number that was inside it shouldn't be the same. So I saw -1, -1. I was like, this doesn't make sense. So yeah, thank you.
The value can be the same, like -1 here, -1 here.
Yeah.
It just when we are
index,
when we are
the index must be different.
Yeah. Okay.
I think it's the index, not the values.
Such that E and K. Yeah, it's the index, but they probably didn't make this clear here. But like, so num E and num G, because this, oh no, it's clear. So num E and num G is like, so this is the index, right? But this is the index of this num right here. So it's like saying E and G and K, they should not be equal.
Yeah.
So if you did use E, which for example, E here 0, 1, 2, 3, 4. So if E was 0, G and K should not be also 0. Basically, if you did use this number at sum of triplets, you can't use it again in same combination. Right?
Yeah.
Exactly.
Does make sense now, yeah.
Exactly.
Yeah, so the index of basically saying if I combine this number with this number with this number and they give me 0, that will be unique element of 3 numbers. So I can't combine this number with itself, so twice. I can't use the number twice.
Could you zoom in a bit?
Yeah. Is it good now?
Yeah, it's good. Thank you.
So yeah, I can't use number twice, and we need somehow to find duplicates. So in this case we have number 0 and index 1 and 2 together, they give us 0. 1 and 2 and 4, they give us 0. 0 and 3 and 4, they give us 0. And we return 1, -1, -1, 2. Yeah, so -1, 2, -1, so the order doesn't matter. And we return -1, 1, 0. Oh, so this one are the same. That's why they put it only one time here, because these are the same. If you notice, it's combination between, wait, no, they're not the same, are they? Oh, there's no duplicates.
They are not the same.
But I mean, they are the same because -1, 1, 0. But they're not same elements. Wait, let's see.
Yeah, they are not the same.
They're not the same element, but they only put 1 here. So basically, if the triplets have the same numbers, they should not be added. So this triplet is gonna be what? Not -1, 0, 1, and this triplet is gonna be 0, 1, -1, right? So if we add this, we should not add this too.
Oh my god.
That's crazy.
Look, come on.
Okay, is the problem clear?
Yeah.
It's clear, but I think they did that. You know, you said you shouldn't give two results that are the same, but they did that. They're like numbers
But
1 plus 0 plus 1, and the next line is 0 plus 1 plus minus. They're the same. So you can kind of get the same result, but in
wait,
different order.
you mean -1 here, -1 here?
No, I meant
Here?
the two lines, yeah, the one above it and yeah.
But they didn't put it in output, so this part is just
Oh,
explanation.
discarded this. Okay.
So
That makes sense now.
it's not clear. Okay, so we have. Okay, we'll have to meet you. Please, if you have like a read mic, that means I did meet you. Probably have background noise. Just write something in chat. I will unmute you. This array is the output. So the output is this. Output is this. So it's like so the problem is let's take it like so we have this. What's the first number? -1, 0, 1, 2, -1, -4. So this is the problem, right? And now if we combine this number and this number and this number, this is gonna give us 0. Now if we combine this number with this number and with this number, this is also gonna give us 0. Now we need somehow to get all the number that give us 0, but this number right here, let me find. Where is it? This number with this number with this one, 0, 1, 2, 3, 4,
-1.
and this one.
Yeah.
This one also gives 0, but we're not gonna return an array of like -1, -1, 2, and -1, 0, 1, and 0, 1. This is the value what you write inside, the value of this, and -1, because these are the same as this. Like this combination are the same as this combination, because you basically here you start from -1, and then you find 0 and 1. And here you start from 0 and you find -1. So it's combination of same value. So -1 is here, 0 is here, 1 is here. So somehow we need to eliminate duplicates. Now let's read this again, see if it maybe made it more clear. So given an integer array nums, return all triplets nums e, nums g, nums k, such that e and g doesn't equal g, e doesn't equal k, and g doesn't equal k. So three of them are elements unique. And nums a, and nums g, and nums k, some of them equal 0. Notice that solution set must not contain duplicate triplets. So it's not the element inside not duplicates, and must not complicate duplicate triplets. I guess it's not clear a lot until we see it here when they use this. But maybe when they say duplicate triplet is also including this. This one 0 1 1 to return empty because the only possible triplet does not sum up to 0. So there is no tree number that you do sum and give 0. And here it's possible 0 plus 0 plus 0 it gives 0. So this is the triplet that give us okay, who did not understand the problem? Is it clear, the coach?
I have a question, please.
Yes, please.
Well, I understood when you all explained the problem, but the first example of -1, and 2,
Yes.
I don't feel like it applies to the condition the problem put about I not equal to J or K.
Okay, we can try it.
I don't...
Yeah, we can try it. So -1 is nums. Let's just call it nums. What is the A here? Is 0, right? E is 0, right?
Okay.
Plus nums. Index of -1, which is here 0 1 2 3 4. So index 4, which is J, is 4. Plus n2. 2 is here 0 1 2 3. So index 3. So K is 3. So E doesn't equal G doesn't equal K, I believe, right? Because this one is 0, this one is 4, this one is 3.
You're talking about the index, not the value itself, right?
Yeah. Yeah, so
Okay.
E right here is the nums E. So they're talking about
Okay,
this
now
E.
I get it.
Yeah.
Okay. Thank
Yeah, you're welcome. So basically they're saying don't use the same element twice.
Okay, thank you.
Yeah, no worry. Someone asked question, if -1 is E, -1 is aren't E, -1 is G, aren't they equal? So it okay, so you have the same question. Okay, I hope it's clear now. Okay, so the problem is clear right now, right? What is going about? Now we can you want to brainstorm, guys, how we can solve this?
Yeah, of course.
Okay, who have some solution? Who have like idea how we can think about this? I don't have a solution, but I think sorting will help.
Like sorting the values inside.
I believe so. I believe so.
I don't think so, because the output is like is ordered. So the first array is -1 -1 2. Like he check first the -1. If we are sorted, the order of this array is like a I don't know.
What recurs? They don't consider them equal if they are in the same solution. If nums has more than one appearance of it, but consideration them equal across different solutions.
So if I may come in, Manchester, I think
Yes,
if
please.
you use 3-pointer, okay, I think if you use 3-pointer approach alongside with the sorting the arrays, let's start from there, and then it will help. Using 3-pointer approach and trying to sort the arrays.
Okay, we can try that. 3 pointers. So first the array is not gonna be sorted, so it's gonna be -1. 0, 1, 2, minus 1, minus 4, and then it's gonna become minus 4, minus 1, minus 1, 0, 1, 2. And so this is gonna be our array. And then 3 pointer. Okay, wait, let me read the chat. They consider them equal if they are in same solution. If nums has more than one appearance of it. I didn't understand well. They're like this one, these two, but consider them equal across. Yes, please.
So basically, in one solution, if I have two minus ones, then they are at different indexes. So then they are not considered equal. So you can put as many similar, I guess, numbers in one solution, but across different solutions, they're considered the same even if they are at different indexes. So the minus 1 at index 0 is not the same as minus 1 at index 4 when it comes to the same solution, but they are the same if we consider like multiple solutions. That's why we cannot have like the two similar solutions. So it's kind of like brain fucky, but okay.
Okay, so basically if we use minus 1 element, so now we have like to care about duplicate of the index and also the value. So minus 1, 0, 1.
Can I just...
Yes, please go ahead.
Comment? So, as Sarah said, we can't have duplicate solutions. So I think we can just use the solution. So if we find a solution that is minus 101, we shouldn't use anything that will give us minus 101 again. So we can skip any solution that gives us this same set of numbers.
Yeah,
that's
I think sorting will help us with this, because if we start from minus 1 and then we keep going with other elements, so think of this like a two-sum problem mixed with the three summary problem. So we're gonna do minus 1. If we start from minus 1 and then we keep going through other numbers, and we find like when we mix 0 and 1, it gives us 0. Then we're gonna go to the next element, which is 0. We're gonna keep going and we're gonna maybe find 1 and minus 1. That's gonna give us 0. But somehow we should not add it. Interesting. Okay, let's keep going with the solution that we start the for loop and see how it will work. Brute for approach, we index by index. Once it's set up length 3, we are returning the whole result first, then we now handle duplicate after. Yeah, I think brute force will work. Okay, I already work on this this task. So with 3 pointer it will work. It's the best solution is the 3 pointer, or like 2 pointer but one main pointer that go on each element and 2 check the others. Yeah. So how do we do it with 3 pointer? I don't remember, but I can try to remember again. So we put 1 pointer here at the start. Wait. Okay. happening today? We have a lot of noise. Okay, so one pointer in the start. One pointer in start. And we're gonna have one pointer here and one pointer here. Okay, I'm trying to remember. Okay, so this is the format of this algorithm. Is one here, and what we're gonna do is we're gonna keep looping on each number, and on each number we're gonna have this two pointer that's at the right side of the array after we sort it, of course. Now what we're gonna have, what we're gonna do is we're gonna do like the equation s, or like a result. Let's say result, or like sum. Sum is gonna have the e, the element. Let's call it what do we call this? So this gonna be left and this one right. So we can call this elements plus left plus right. So the element that we are in the array plus left plus right. So it's gonna be sum plus -4 plus left -1 plus 2. And so how much is this one? -4. Here we go again. -5 plus 2. So -3, which is not what we want.
0. Yeah.
Which is not what we want, right? And here we're gonna have like 3 check after we find this result. The first check gonna be if s is greater than 0, and second check is if s is less than 0, and the third check we can do else, or we can make it clear and say if s equals 0, which is the one that we're looking for, right? Now we don't know what we're gonna put inside, but we can think about it. If this is -3, what that mean? We are looking for 0, so that means I need to add some value to push this to 0, right? I need to add numbers, and because this is sorted, we know that this is gonna be less and this gonna be high numbers, right? And so we wanna try to get the high numbers. So it doesn't make sense if I move this here. It will make sense more if I move left to the right, right? Because I want the higher number to add it in the next iteration. Now we are loop, so this is gonna be 2 loop. The first loop is this one, and inside it, this 2 right here. So the first loop is just holding -4, and this gonna keep going between all the numbers. Then we're gonna go to the next number, then go to the next number, and then we're gonna stop here. We're gonna stop here. Why? Because there is 3 number. We can't, there's no need to go here check, because there's no third number. So there is no triplet here, and this combination of numbers, it's gonna be already visited maybe, right? Because if I pass on all the numbers from here, and then I come here, pass all the numbers, then I come here, pass all the numbers, come here, pass all the numbers, then I kind of visit all the values. So let me not confuse you now. Now we say because this is negative, we're gonna move left to the right. So next loop, we're gonna change this left right here. So if s is negative, we're gonna left plus 1, left plus 1, and then the loop, this loop gonna start again. And what's gonna happen now is this one was before -1, and now also gonna be -1. So -1 maybe we can do something about this. -1. I think it's fine. I think it's fine. Okay, so -1, -3. Then we're gonna do again left plus 1. It's gonna move, right? Because it's still the same value. It gives us -3 again. So again, we're gonna loop. It's gonna go to 0. So this result's gonna be 0, -4 plus 0 plus 2. It's gonna give us -2. So -2 is still not 0, and it's still less than 0. So we're gonna move again the left pointer. So here is it. And now it is again, we're gonna calculate. So it's gonna loop. Then we're gonna do -4 plus 3. It's -1. -1. -1 is still less than 0, so we're gonna move left to plus 1 more time. And because left and right are not less, left is not less than right, this loop right here gonna stop and or like go to the next element. So let me write it here. So we said all these loop are inside the main loop, which is this one that's run through 4. So left and right, so it's gonna be while left less than right. So while left less than right, I'm missing something. So this is the loop right here, and so this is the loop that turn on the S while loop. Okay, and this loop, so the while left here is this one inside, and this one also inside another loop. I think it's gonna be 4. That's gonna turn on each element of array 4 for each element of array -2. Right, there is no need to loop on the last two elements because we're looking for 3 elements. Okay, I guess that's it. Okay, let's see if it was still working. While some. Okay, so we reach here. We said this loop gonna stop. Now if this loop gonna stop, then we're gonna loop again on the next element for each element, right? This gonna stop. This loop gonna go to the next element, which is gonna go here. Again, if it's gonna go here, what's gonna happen? Gonna go here, and left and right gonna reset, right? Probably gonna write. So when did we reset? Probably gonna reset before the while. So reset here. Reset the pointer, left and right. Okay, we reset them, and then we're gonna calculate and see if we're gonna find this number. We're gonna follow the same structure. So while left and right, so left and right here, so the loop gonna enter, gonna do some element, which is -1 in this case. So -1 so -1 plus left, which is -1 plus the right, which is 2. What is that? -1 minus 1 is -1. -2 plus 2 is 0. Okay, we found 0. Now if we go again to check, it's not left, it's not less, it's not greater, it's equal 0. So what we're gonna do here when it is equal 0? I don't remember, but I think
Would we append it to the answer list or something?
to create a list. Okay, let's see. Let's create a result list. Wait, what? We should return a list, right? Okay, so I have a list. So we can append it to. Are we gonna append it? How we? Oh, so we're gonna append the 3 of them inside the list, and then we append it to the main result one.
Yeah, we create an empty list at first. We take those results and make them another list and append it in the list.
Okay.
So we can use
Can you use what?
set.
Yeah, we can.
Yeah, but they want the result as a list.
Yeah, for duplicated meta arrays. Same.
We can do it. So results that sets, but is that gonna help?
I don't know. Okay.
Maybe it's gonna help because we have duplicates, but the duplicate we have is weird a bit because they are not order. But maybe we can order them. Okay, let's. I'm not sure to be honest if it's gonna help here. But the solution that I did, it did not use it.
Oh, okay. Just the idea.
But I think if we use it, we can. It can help us because we can sort the array itself and then push it. Then automatically it will not have duplicate elements like this. If we sort this and this, then we add them, it's gonna eliminate the problem. So let's go with the set.
Yeah.
So set result set. Now here we're gonna. So we said if it is 0, we're gonna append this and this and this. So results, which result is a set, we're gonna append or add. Set is add. We're gonna add inside it array of elements. We need to sort it, right? Maybe sorted, then inside that element plus left plus right, and then we're gonna add it to the result. else? What else we can do in is equal 0? So if we add the numbers to the results, then we can move the left and the right. Now if the numbers right here, if the numbers, this one is also -1, and let's say this also -2, there is no need to add what is called the loop again to try this one. We can skip them. So if it is 0, we can add a check if the next number is equal to the number that we are in. If it is, do +1 to the left to skip it, because at the end let's do a normal case so you can understand what I mean. So after we found this 0 right here, we need to move this right here and this right here, right? So the while loop can process -1 and 0 and 1. Now to do that, we're gonna do here, we're gonna do move left +1 and the right -1, right? That is the normal process, but in same time, okay, I think if this one is a bit complicated. So the idea is like when you check for 0, you also check if this one, the next one, and the next one for the right is also equal, because if it was equal, what you want to do is move the pointer right here and pointer right here. So when you go to the last line that will move in general, it will skip that element. So for example, this one was equal, I'm gonna move it here, right? Like this check gonna be here, move pointer from duplicate. So it is right here, I'm gonna check for duplicates. Yeah, it is, I'm gonna move it. So when I go to the last line, move left and right +1, it's gonna happen, this gonna move right here. And if there is, now it is close, but let's say this 3, and the right gonna move right here. So this gonna be the next process. Okay, it's okay if you're not following. I'm gonna try to explain this more better. I don't think it's necessary, but because now that we are using sets, we don't need to do that, right? Because sets, even if this one was duplicate and we try to add them next turn, they're not going to be added to set. But that was the solution, how to avoid duplicates when you are using normal array. It's just you're gonna check on each number you are in, check the next one if it's equal, because we are sorted array, right? So if I have -1 here and they have another -1 if in same array, it's gonna be the next one, right? So I can jump it and skip it basically. This way avoid duplicates. But because we're using sets, we don't need to do this process, so we can just move left and right to the next element. So we did process -1 and 2, so the next element is going to be 0, and this also going to be 1. So we do this move in the while loop, right? We didn't enter here, we didn't enter here, but we did enter here, and there inside move left and right. Now we're gonna loop again as long left is less than right. What we have here, -1, do we have 0? Please, if you have question, stop me. Write in chat, someone writes. Thanks for such. I'm leaving now. Attend some task here, but you're sure. Okay. You probably watch recording now. Hey, hello YouTube. So 1 0 minus 1 0 1 minus 1 and 0. Here we go again. Maths again. So 1 and 0 1 minus 1 0. So this solution also gonna give us 0, right? Now is this one also as the other one? What was the other one? I forgot. The other one was minus 1 2. Okay, so they are not the same. So what's gonna happen here? It's give us 0, so it's gonna go if is left less. It's not great. We still don't know what to do in great, but we probably assume what we're gonna do. Now s equals 0, right? It's equals 0. We're gonna append the results to the set. So let's say this is our set. It's gonna be minus 1 0 1. So just assume this here is set. And what else? We're gonna move left and right. So the left we're gonna move it +1 and the right -1. So we notice here the condition is not true anymore. Left is not less than right. So this loop cannot stop. And this loop is inside the main loop that's looped through all the elements of the array, right? Which is this green pointer right here, which is pointing now on -1. But because this loop stop, the code gonna stop and the loop gonna loop again to the next element, which is -1. Now here we notice something, right? -1 again. So it's gonna be the same combination, same work. So it will be nice if we add here a condition to say if, so a condition to skip this to 0, right? It makes sense, right? If we process -1, the number -1 with -1 0 1 2, it doesn't make sense to process it again because they are the same numbers. So we need some equation here when we loop and it's the same number. We're gonna do continue, like continue to the next number. So what we should run to do that? What will be the condition? We can
we
do
must
if,
keep track of the number.
yeah, like if
We must keep
number,
track of it. Element, the previous element.
okay, if elements equal the previous elements, right? So we can do like, if we have index, we can access index by -1. So if elements, or like if current element equal previous elements, continue. Continue means skip this iteration.
So we have to also define where we're gonna keep the element, the previous element. Somewhere in the code we have to keep it.
I mean, if we're using E, for example, E, we can just do nums -E -1.
Yeah, it's good. Yeah.
Omar, you were gonna say something.
Yeah. So, what is the reason of doing this condition if current element equal to previous element?
Okay. So we were treating this number, right? We were treating -1, and what we did is we treat -1 with -1 and 0 and 1 and 2. So we did combination of all this number. So we did -1 with -1, with 0, with 1, with 2, with all of them, right?
Okay.
Now we finish them, right? Now we are gonna go to the next number, which by luck it's also -1. Doesn't it make sense that it's gonna be the same results? Because we're just gonna repeat what we did before. So to optimize is like, okay, if this number is equal to the previous one, just skip it because it's gonna give us same results if
Yes.
it have.
Yes, yeah. Correct.
So this one, like this, we're gonna skip it, and we're gonna end up in 0. Now 0, we're gonna reset the pointer. There is it. Reset the pointer, which means this gonna be here. This gonna be here. So the 3 pointer always like this one, the main loop, the for loop, and these are the while. And if this was E, this gonna be E plus 1, and this gonna be the end of the array.
End of the array, okay.
And our for loop, it's only loop on each element of array minus 2. So in this case, it's gonna loop on this zone right here. So this is actually the last loop, because we are looking for 3 numbers. So this is the last 3 numbers. We can, if this go right here, we're gonna go outside the array.
To French.
Yeah. Because we wanna check the combination of these numbers. So here we're gonna do the same again. We're gonna reset the pointers if it is current number. If not, so we're gonna continue. We enter the loop. And what we're gonna do is we're gonna create sum. I'm gonna put element, which is 0 in this case. I'm gonna write it here. Here is it 0. And left, which is blue, is 1. And plus 2, which is right. Let's see what value gonna give us. So this one give us 3. 3 is not equal 0. So is 3 less than 0? No. Is 3 greater than 0? Yes. So what we wanna do, if this number is greater, we wanna move the right to the left. Why? Because we have this is sorted, so the left side is negative numbers or less numbers, and the more we go to the right is we're gonna find bigger number. So if this combination of this pointer give us a great number from 0, we wanna reduce the value. So we wanna reduce the value by moving from 2 to 1, right? To move a bit to less. It will not make sense to raise the value. So left to raise the value, and right to reduce the value, because they are sorted. So in our case right here, when we gonna reduce the value, it's gonna happen, right? Plus 1. Basically the while loop gonna stop, right? Because this is the only combination we have. So right gonna stop, and if this stop, this gonna stop, and we're gonna return our array, which have this one. Let's make sure it is the same value they return. Is it the same? -1, -1, 2, and -1, 0, 1. So it work. It's same numbers. Now I hope this algorithm clear, understand. If you have some question, please tell me before we convert it to code. So this is the pseudocode. If you understand it, you can code it with C, Python, JavaScript, doesn't matter, as long as you understand it. Okay, who have question? What part is confusing for you, or if you want me to repeat some parts, I'll be happy to do so. Do you wanna maybe go one more loop? Clear? Okay, let's do it.
Can I repeat it again, because I'm still kind of confused.
Okay, so let's do it again. You said confused. Is there like some specific part you're confused about?
Yes, like how you move the pointer and like how you do the calculation. Like I'm still trying to grab the concept.
Okay, so this for right here and the while inside it, is this clear? Can you confirm? Can you repeat?
I said understand the while. Just
Yeah.
explain.
Yeah, like the for and inside the while, like the concept is clear, right? That we keep looping here, then we move this. So we have this for right here. Let me put it in color green. And this one right here, the while is the left and the right. So we're gonna start from 4, which is this pointer right here, and we're gonna loop on all the elements right here by these left and right. And while we looping through here using while, this gonna still be here fixed until we done with this, and then we're gonna move this for right here. So again, we're gonna do the same. So basically we put a fixed number, and then this left and the right, which is right here, element is fixed, and left or right keep changing while we're looping. And then when we're done with this zone, we go to the next zone, which is here. Again, we go to this here. Again, we go to this here until we finish the array. Now let's do a one loop, and let me if it is clear. So we start right here. -4. So we reset the pointer left and right. Okay, here is it. They are reset. If the current element equal the previous element, continue, skip. If current element, which is -4, equal previous elements, in this case we just started, so we don't have previous elements, so we just skip this. While L less than R, which is right here, we're gonna create some summary of 3 elements. So in this case, -4, -1, and the right is 2. -4 so -5 and 2 is like -3, right? Is it clear so far, Morba?
Yes.
So 3, which one gonna enter? Can you tell me? Which condition gonna enter if S was -3?
Like if S is less than 0.
Okay, so what's gonna happen?
Then the left, like we'll move the pointer from the left forward by 1.
Okay, that's what's gonna happen. Then we're gonna loop, right?
Yeah.
And then the sum gonna change because the left change. Now the lefts become -1. So because this is -1, so it's gonna stay the same value, -3. So it's gonna do left. Here is it, left. Again, it's gonna loop. This time is 0, so -4, so it is -2. It's still less, so it's gonna do plus. And this time 3 and -4. -4 plus 1 plus 2 is -1. It's still less, so it's gonna stop the loop, right? So far it's clear? Because this one is not clear. So what that means, it stopped the loop. That means -4 with combination of all the right numbers, it didn't give us 0. So now we're gonna move to the next number, -1. And basically we're gonna do the same. We're gonna check the right number of it. So we're gonna reset the pointers. Here is it. We reset them. We're gonna check if -1 equal the previous one. It doesn't. So we are working new combination. And we're gonna check the elements. Elements in this case is -1. And left is -1. And right is 2. How much is that, Morba?
-1.
So -1 plus -1 plus 2.
0. I thought it's 1. 0.
Okay, which condition gonna enter and what's gonna do?
That is where s is equals to 0.
So
Yeah.
what's gonna do?
So it's gonna append the list into
the set, right? So it's gonna append, if we said this is our set, it's gonna append -1, -1, and a right is 2 after it did sort them.
So,
Yeah.
And then it's gonna move left and right?
someone say, first of all, we need to sort the given list, isn't it?
Oh yeah, you're right, we forgot to write it here. So sort the given list. Okay, there's
Yeah, that's confusing me, bro. I saw the list sorted. I thought, what the heck is this for?
yeah, now it's sorted because the original list is this one.
Yeah.
Okay, so we added to the set and we're gonna move left and right. Is this clear, Morba?
Yeah.
Yeah.
So
right now
is your confusion go away, or like you still confused?
No, I'm no longer confused. Thank you.
Okay.
Thank you. I'm getting.
Okay, so that's basically we're gonna keep doing it until we finish with this number, and then we move to the next number, and then we move to the last number.
Yeah.
You were gonna say something, Omar?
No, bro, it's clear.
Okay, so how we gonna transfer this to code? Let's see. What we can do, I'm gonna put this here and write directly because okay, let me remove this and we try to write it from beginning. It's not gonna be the same because the one that I worked before, I did use array, not set. So I had to do some condition here to remove duplicate. But I think with set we're not gonna need that.
Actually, the set idea is brilliant.
Yeah, it saves a lot of time. Actually, look, so whoever said set, you are genius.
Yeah, it's AU.
Our
I
genius.
didn't think of it at first because I saw that they are in a list, so automatically went to a list now. But he was intelligent to think about that.
Let's clap for AU.
Which
Hey, AU.
which one?
Okay,
Why?
so we said we're gonna sort the array. Okay, how are we gonna sort the array? Using split list, right?
Yeah, it's a list.
So list or nums that sorts. So this gonna sort it.
Yeah.
Now we're gonna create results.
Solutions or results.
And we're gonna put inside it a set. And then for each element of array -2, we can use enumerate, but we need the index and enumerate take performance. So we can use for and then index and then n length of names, right? And length of nums gonna give us so the range. So in the range, wait, in a range?
Yeah.
The range of length of nums plus -2.
Okay.
Because we don't wanna these two elements here, right?
Okay.
Last two elements. We wanna just loop through this one.
Okay.
Now we wanna do something. What is this something? Is reset for reset the pointer. I don't see chat. So if someone writes or let me. Okay, if someone writes to chat, I will get notification. Now we said reset pointer left and right. So left gonna be on e plus 1, right? So if this was oh my god, this is yeah, so if this was e, this gonna be e plus 1.
So
left's gonna be nums e plus 1. Oh no, it's left is a index, so it's gonna be e plus 1 directly, right? Yeah, because we are while left and right. Yeah, so left is index, which means left and right. So the value of left is gonna be index, so we can use it later to access the value, of like here, left and right. Then right's gonna be the last number, right? So it's gonna be length nums minus 1, right? Because length it give you, for example, here sixth number. Length nums is gonna give you sixth number. It's gonna give you 6, but last elements have index 5, not 6. So minus 1, so we get the correct index. Okay, we did reset the pointer. Now if current element is equal previous element, so if current element, which is nums e equal nums e plus 1, e minus 1, e minus 1.
Yeah, e minus
previous element, we're gonna
but you have to check if there is an e minus 1.
Okay, so e should not be 0 because at the start we don't have. So if e is greater than 0, e greater than 0, and so because if we are here, we don't need to check for previous one, and e here is 0. Then if we move to the next element, we can check with previous one because e is greater than 0.
So if I greater than 0, right? But not less.
Oh, greater, yeah. I always feel this. Continue. Continue is just like skip this for loop. This iteration, go to the next one. So we did this. Now while L and left. So while left less than right, what we're gonna do is s equal minus 1. So we're gonna do s call it sum element, which is nums e plus left plus right, not like that. I think plus nums left.
Nums left.
No, because that is just the index.
Yeah.
So maybe we should do L on the right so it's become shorter. Left, right. Okay. We said after that we're gonna check if s. Let's do this also. If s 0 left plus 1, if is greater than 0, right minus 1. Actually I have mistake here, minus 1. Else it's gonna be the check for 0. We can just do else and then results, add, sorted. Then inside we're gonna put nums e and then nums left and then nums.
I think set will not accept a list as a value.
The sort.
No. The set.
Add
Result.
doesn't accept this. So we need to sort it, then add it here.
No. The set itself as a data structure do not accept the list as input.
Oh, I can't put inside. So, for example, if we have results, set, and then results, add, then 4, 5, 6, print, result. It doesn't accept it.
It's just a string. I think so.
How we can use set? I think we can't.
Maybe we can make the numbers inside a set, and then afterward we can convert them. Like instead of using a list inside, we use sets.
Oh.
But the result might have duplicates.
Yeah.
Yes, you need just to check if.
Okay.
If it
is there a way to add array in sets?
I think you need to.
Or we can convert them.
Add another parenthesis. 2 parentheses inside it.
2 parentheses?
I think we guess.
So it's gonna be tuple.
Yeah.
But how are we gonna convert it?
Cast it maybe.
How convert if I add
You want
in tuple to set? How I can convert them to list?
Maybe cast it.
I think like this.
Oh, I can do list.
Yeah.
Okay, we can do this, but it's but I want so maybe list or
maybe 4. You're gonna do like 4
set of tuple. I want to make it list of list.
Just yeah, that's what I want.
Okay, we can use something like this. Okay, so let's add it now as a tuple. We're gonna sort them. I sorted work with the tuple. I think it worked. Oh, tuple does it? Can test it, right? So tuple results. Add. Say this is 10. If I did sorted.
It's sorted.
Sorted.
Sorted return a list also.
Oh. Oh God. I don't know how we can use tuple then. Okay, let me chat. Attacker, my network.
You can pass the sorted list to a tuple constructor.
Wait, Sabah did say that Minatal used tuple and did pass. Really? Still pass? Are you sure? Okay, I guess we can use tuple. Okay, let's use tuple. So now the sorted is the key. But we can't sort tuple. How I can sort tuple and add it to set. Can do tuple sorted list. Oh, so you need to cast it to tuple. Okay, I see what you're doing. Okay, this is good. We're learning so much. So this is tuple is also gonna give us list, and so basically we just need to cast a tuple here. If someone don't know yet Python, trust me, just when you're gonna learn Python, this is gonna be, you're gonna understand this, so don't be scared or think that this is something complicated. Okay, so tuple sorted, this gonna return list. Okay, I think this will work. We test it. Tuple. Okay, 4, 5, 10. So it did work. Okay, so we added here, it's sorted, so we guarantee there is no duplicates. What was the second part? Move left and right -1. So we're gonna move left +1, right -1. Then other than that, we're gonna loop for, gonna finish, then we're gonna return result. Let's check it. Closing parentheses, line 18. Okay. 1, 2, 3, 4. Expected line 9. If run left cannot access local variable left. Okay, this one L, this one R, this one L, this one R. Okay, we have some cases wrong. Expected -1. Okay, let's see what output. Else. What could be the problem? So here, did give this one correct, but
no, they're not correct. I think there's a problem with the sum somehow.
This
because
one.
it didn't check, for example, -4 -1 +2 is not, shouldn't give it as
Okay,
out.
maybe this should be s equal 0. If s equal 0. Wait, did I reset pointer? I did reset them. Okay, run. Oh, okay, so this one, it was added here. Okay, let's submit. Okay, 47. Okay, not bad, not bad. That was
Yeah.
I think one way to make it faster is to skip the last sorting, because we have L, which is bigger than E, and then R is always bigger than L. So technically they're already sorted. Maybe?
Okay, we can try it. So can do like this. Submit. Okay, it did work. So they are sorted. because what? Because we sorted the array, right? So we're not gonna, and because we skipped the last two number, maybe? I'm not sure.
I mean, since the array, first of all, is already sorted, and then so the index of L bigger than E, right? So because L equals E plus 1, so L is automatically bigger than E, and then R is at the end and is always bigger than L. So makes sense.
Okay, so
I think we can also increase the time complexity there.
we can also what?
I think we can also further increase the time complexity there, because I noticed that we calculated the length of norms, like
this one.
end time. Yeah, maybe we can assign a variable to it, like let's say length equals to length of norms, so we don't have to calculate the length of norms.
Oh, no, it doesn't calculate it every time we loop. It's only calculated the first time, that's it.
Yeah, the second, line 8, we have R equals to length of norms minus 1. So whenever we go to the next iteration,
yeah, we can do that here, but the error can change, I think.
No, I don't think.
Yeah, because every time we loop, we need to calculate. We need to reset the. Oh, you saying the length? We can put it here. Okay, yeah, I see what you mean.
Yeah.
And we can put it here, and then we put end.
Yeah, something like that.
That's smart. It did help. This one is not accurate, but okay. So there is still more to LeetCode. So it is a bit a while. So understand if you wanna go sleep or something, it's okay. You can watch recording later, but we will continue. First, so this is the solution that I did. It was using using list and skipping duplicates by this, and it like 80%. So it is the same code if you notice. It have this to skip if the number is it's like if the number greater than 0, because if the number greater than 0, let's say we loop here, and we found 5. That means here it's gonna be 6, here it's gonna be 7, because it's sorted, so it's break the loop. So if the number is bigger, automatically break the loop. However, we move to the binary tree traversal, which is the next LeetCode. Let's see. So this one is a bit easier than the one that we saw. So this one is gonna be more faster. So given the root of binary tree, return the level order traversal of its node value from left to right, level by level. So give us this binary tree, we should return 3. We should return 3 right here. Then, so this is level, let's call it 1 or 0. Then 9, 20, 20. So this is level 1, 9, 20, and 15, 7, which is level 2. So that's it. This is the problem. Given the root of binary tree, return the level order traversal of its node from left to the right, level by level. If it is 1, it is 1. If it's empty, it's empty. So what do you think, guys? Is there any question about problem? We didn't understand it. This one, it doesn't need a lot. me execute the script. Okay, so how we can solve this? Anyone, what do you think about BFS? Because it does go through level by level and we don't visit the same node twice, right? So if we use BFS, we can solve it more easily. What happened? Okay. Any idea? Do we go with BFS? We can even do them both. We do one BFS and one DFS. So BFS is gonna be with Q. So if we put a Q right here, as always, we start from the root. So we're gonna put root inside. And we're gonna then, while Q is like, while the Q is have something, we can pop it, but we will need, because we're gonna traverse levels by level, so we will need like one for loop inside. So like I'm trying to read what Sabah saying. Node level and append node to the right index. With the BFS, or are you talking about DFS?
I've done it the same with both, but basically you store both the node and its level, and when it comes time to append the node, you append it. So the solution would have different, it's a list of lists, and the level would be the index of the list. So 3 would be at index 0, 9 and 20 would both be at index 1, 15 and 7 at index 2, right? So you append the node to the corresponding level. It works both with recursion and iteration.
Okay, but does it like add it to the queue and then like pop it and then add their children to the queue?
Yeah, you go like usual, how you usually go with add in and pop in and.
Okay, so
yeah.
In here we're gonna add it to the queue. Okay, let's create. So we need a variable level, right? So level gonna be a array, which is that's gonna hold like 3, 9, 20, 50. So it's probably gonna be inside the while. So the results, we will need results. That's gonna hold the levels. And now we're gonna, do we pop before the loop or after? So we can, so if we think this is a level 1, okay, before we enter the loop queue, we're gonna add the root to the queue. So there we're gonna add a root to the queue, which is 3, and then we're gonna do a for loop. loop on element of current level, which is what's inside the queue. So take snapshot of length of queue. So this will probably be confusing now, but it will make sense after I write it. So while in the queue we add root tree. Now level is empty. We reset level because every time we're gonna go here, go from level to level, we need to reset the level. Then loop on element of current level. So this level, when we add it, it was just 3, so there is only one node. Now loop on element of current level, we take snapshot of the length of queue. So basically we're gonna do 4 one time because there's one element. So I hope this one is clear, because when we're gonna be adding later, we will need to loop. So for example, next loop we're gonna add 9 and 20, so we're gonna loop twice. So loop on element of current level. Now we're gonna pop it, so pop the number 3, or like DQ element. And after DQ'd elements, we will need to add its children to here. Now here where I think Sabah did node level 0, right? Something. So my idea is like to add it to the level and then we add it to here. But I think you did something different here, right?
I'm kind of not understanding the loop part, since you're gonna use the queue how you usually use it, appending element by element to it. So inside the queue, they're not lists of lists. They're just
okay,
just
so
units.
Okay, can you show the code maybe? Because
Okay.
I'm not following. Maybe you did loop on all of them and you add them to...
So you go through it the way you usually go, right? If you just want to put them together without the list of lists kind of thing. So you go through each node and then you add it to the queue, you pop it left and right, and then you go. But the issue comes in when you want to append it to the solution array. That's where you have to do it like with a tricky, because you do it inside of an array. I'm not explaining this.
No, I think you're talking about this part. So you did create queue, you append it with the 0, and then okay, I see. So each time you traverse, you increase the level. Each time, okay, I see what you mean. It's like you have a memory with each node you add, right? Okay, that's smart. So node level queue pop left. Okay, I see what you mean now. I see what you mean. I guess I will continue with this one, and we can check it also this one and learn from both. This one doesn't add the memory to this. It will just put them in the results and the level, and then push level to the result. Okay, so DQ'd element. So we did remove this element from the queue, right, to process it. So in the BFS, that's what usually we do. We start with the root, we add it to the queue. Then we inside the while loop we dequeue it. Here we did inside a loop is like it will make sense later. We're not gonna go down just because we will need to process level by level. But I think if you did use this here, you don't need to do loop because you have memory. You're gonna, if you did use the Sabah solution, you can just save memory inside the queue, which is smart. I think that will have less time complexity. So dequeued elements, so here's it. We dequeue it, we're gonna process it. After you dequeue is the pop left. And what we're gonna do now, we're gonna add it to the level. So add the, what we're gonna add the value or the node itself? We're gonna add the value, right? So node value. So add node, right? Not add, or like append to level node value. What else? Now we did append this to the level, which is gonna be 3. Now we're gonna append this, but not yet because we still have. We're gonna append it to the results after we finish this loop. So first we need to add the left and right to the queue. So here in the queue, we processing 3, so we're gonna add 9 and 20. 9 and 20. This is for the next level. It's gonna be processed in the next level. And append to the level node file, and then we're gonna add to the queue left and right. Here's left and right, we add it to the queue. Now that we finish, so the loop finish looping on the level 0, this one, it's gonna stop. Now notice something, even we did add 2 elements to the queue, this one did stop, because here we're gonna use a snapshot of the length of the queue before, so it's gonna be like 4 range length of the queue, so this is for loop doesn't update the queue every time you loop. And after we finish for loop, we're gonna add the result, or like append level to result, and then we're gonna have 3 added to the result. And now we're gonna loop again the while loop, which gonna process now 9. So 9 gonna come here, we're gonna do the same thing, we're gonna dequeue the element, here is it. We reset the level, append to level node val, okay, we have 9. And then we add left and right to the queue, which is 9 have what? 0. So we're not gonna add anything here. And add left and right to the queue, there is nothing. So what's gonna happen is we're gonna loop again 4, right? Because we did loop the length of the queue, and the length of the queue before we start was 2. So we're gonna loop twice. So the first time this one, second time we're gonna dequeue 20. There is it. And then we're gonna do the same, dequeue, append to the level node. Okay, here is it, 20. Append it to the level, so not confuse you. But this is gonna be a result. 20. Now we have level right here, and we're gonna append it left and the right, which is 15 and 17. We start from the right, so 15 from the left, so 15, 7. And then we're gonna do the same. It's gonna add level to result, which gonna bring this level to result, and then we're gonna dequeue this, and we're gonna add it to the level. It doesn't have anything. Then we're gonna loop again. We're gonna dequeue this. It also doesn't have any node, so it's gonna add it to the level, and then we're gonna add the level to the result. Append level to result, and the queue is empty now, while queue, so the queue gonna stop, and then we're gonna return what is called results. Return results. So this is one way to do it. I think using memory is more efficient because you don't need to do this for loop right here. Okay, let's code this one. How we can code this one? Before we code it, is anyone have a question? Who have a question? Da, 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 da. Did you guys sleep?
No, we are here.
Okay, so let's code it. First, we're gonna put results. Add root to the queue. Results. What we're gonna do in results is just gonna be empty. Add the root to the queue. How we do the queue? I forgot. Import something. Did someone write it in chat? Did anyone use the queue? No. Okay. From correction. Okay. No. From collection. Port DQ. Okay, now we need to create a queue. So queue. The queue, this one that we are processing in TQ, and inside it we're gonna put the node 3, right? So let's put it from here. Root, which is 3. We put it from the beginning. Then we say while queue. We say level reset. Then for in range length of queue, which basically saying okay, the length of what having in the queue. That's mean because we're gonna push all level ones and then we're gonna loop on this. So at first we're gonna have only one node because in level 1 we have one node. Dequeued elements. So let's say we have the node, and the queue we do pop left. So queue pop left. So what this gonna do is gonna push 3 from here, and it's gonna pop it and put it in variable node. Then we append to the level node var. So level append node val, the value of the node, which is 3. So this node have 3 elements, have left, right, and val. I guess we can do q append, add to the queue left and right. So q append node left. So probably check if the node left exists before we append it, and then if node right, q append node right. So we append here left and right, and after the for finish, we're gonna append the level array to the result. So results, gonna put inside it level, and then when the while gonna stop, which means we process the all binary, so return results. Let's see if this gonna give good results. Then we can compare the code. If someone solve it, also write it in chat. Level, we can append node val. Append. Did I do some mistake here? What is the result? Node type has no attribute val. Object has no attribute val.
We have defined what node is.
Q. Wait, can you repeat that? Can you repeat that?
No, sorry, I thought we have not yet defined what node is. So it's like as if the node is not even
type attribute val. Oh, I probably should do here if the root is none. If not root, return empty list, because they probably check on case where it was none. Run. Okay, it work. Submit. Okay, not bad. 70. Nice. Who did solve this one? You can paste the code and just check the performance and stuff like that. I think this one gonna have more performance. Oh, 70. The coach, did you do it? Run. No. E.T. This one is really smart. Okay. I was gonna like to do a DFS of this, but the time is probably short, so we're probably gonna jump to the next LeetCode. Who have a question? Who have any question for this one before we jump to the other one? Who did not understand something? But I think I did one with DFS. DFS is this one right here. Yeah. Let's just take a look on it maybe. So diff is gonna be something like this, which you basically do level +1 in each in each recursion you launch.
Please just explain.
Yeah, so you have results empty, then you call the fs function you have here, which is gonna process each node. So you're gonna launch the fs on this one, this one gonna launch on this one gonna launch on this one, this one gonna launch this one, and this one. So when you launch it with the level 0 and here result. Now they all have access to result because it's global variable, or not global because it's a reference, right? When you pass results, so when they're gonna change the results, it will change the main results. So when we launch defs, we check if, so basically we are like creating, so the array, the array result is gonna be like this. So 0, index 0, index 1, index 2. So index 0 gonna be for level 0, index 1 gonna be for index 1, for level 1, index 2 gonna be for level 2. So when I'm gonna launch defs and I'm gonna give it 0, it's gonna go check the results if there is a array, or like the length, or like it's gonna go check if there is index 0 have something. So empty array does not have array element in index 0, right? So if I'm gonna launch defs on level 1, it's gonna go check if this array have the result array have element in 1. If it doesn't have it, it's gonna append the empty array, and then it's gonna append the value here. It's maybe confusing, but let me try maybe explain it in a different way. So we're gonna check if the length result is less than level plus 1. Basically we are saying I want to append this value in the index 2 because I am in level 2, but this array is empty, right? So I need to append an empty array, and then I'm gonna put the value inside it. This case is not gonna be possible because we are moving from the top to down, right? So we're gonna create level 0, we're gonna create level 1, and then we're gonna create 2. So when we're gonna reach level 2, we're gonna have index 0, index 1, and then we're gonna append level 2, and then we'll put the value inside. I will leave the code here. I'm gonna take more block on it. And yeah, and then this one launch defs on each left and right, and it increment the level. And this one here, when we append the node value to the result by using the level itself as an index. Yeah, you can definitely, yeah, you did similar to this one in your code. But I don't think this is BFS, or maybe it is, because BFS we use Q, not least. But yeah, I can see how is that are as the same. I don't know, maybe I'm just hallucinating. I think this is also a BFS. Oh no, you did use Q, my bad. Yeah, this is also Bevis because it have Q. So you did use the same technique here, yeah. Okay, let's jump to this one. This one gonna be a bit complicated, but we're gonna go through it. Let's see. So clone graph. Given a reference of node in connected and directed graph, return a deep copy clone of graph. Someone wanna read it? So each node in the graph contain a value int and the list node of neighbor. So this is the node public int val, public list node neighbor. Okay, it's still here, it's still confusing what they want us to do. Given a reference of node in connected and directed graph, return a deep copy clone of the graph. Okay, here it's gonna make more sense. Test case format. For simplicity, each node value is the same as the node index. For example, the first node with value 1, the second node with value 2, and so on. The graph is represented in the test case using adjacency list. An adjacency list is a collection of unordered lists used to represent a finite graph. Each list describes the set of neighbors of a node. In the graph, the given node will always be the first node with value 1. You must return the copy of the given node as a reference to the cloned graph. Okay, this is gonna make it clear because I know it's confusing, but basically they are saying we're gonna give you this graph which this node is connected with this node, with this node, this node. They are all connected, and you need to return a clone of it, which means a new version of this node. They are not a reference. So in this case it's wrong because it's a reference. 1 2 3 4 1 2 3 4, the same value, but this one is a reference, like a copy. This one we did create node and we give it the same value 1. This one also create node, we give it value 2. Create node 3. And this one is 1 3 4 2 4, so they are not the same, so it's wrong. So this is the correct answer. Now in array here, the array, how they represent this is basically 2 and 4. So this is the list, yes, 2 and 4, and we need to return this list. They are the same, right? 2 and 4 1 3 2 4 1 3, they are the same. But what do you mean? So if you remember, this says something about index. So this is index 1, this is index 2, this is index 3, this is index 4, and they mean 1, value 1 2 3 4. So this node right here 1 is have connection with 2 and 4. So 1 have connection with 2 with 4, 2 and 4, right? So in the index 1 have connection with 2 and 4. So here is it, 2 and 4. The index 2, which is the node that have value 2, it have connection with 1 and 3. Here is it, 1 and 3. And 3 have connection with 2 and 4. Here is it, 2 and 4. And 4 have connection with 3 and 1. Here is it, 1 and 3. So somehow we're gonna do this copy and return the same list using the node. Who didn't understand the problem? I think the problem is a bit clear, but maybe we go to here and try to process it more. So clone graph, I will try to do this maybe fast so we can have a good sleep tonight. So anyone have any solution when brainstorm? We can do this with DFS, we can do this with BFS. It's almost the same one that we did before. Like if we did BFS, we're gonna add it to the queue, then we're gonna pop it. We go for it. Is everyone asleep?
Let's go for BFS or
Okay,
DFS.
Let's go for BFS because DFS is hard to imagine. We can start with the BFS, then we do DFS, but I don't think we can. But maybe if we can vote and see if people want to stay more. So to do it in BFS, we need, or one of the solution is create a hash table to keep up with the visited node, so we don't visit them again. So we're gonna create a hash table where we're gonna save the visited. So let's say we are in node 1, and we have its neighbor have 2 and 4. So but before we understand, is like we need to understand how the node work, the node itself. So the node have value and have neighbor, which is a list of the neighbors they have. So for example, this 2 4 is a neighbor. So the neighbor are this. So the neighbor of 1 is 2 and 4. So let's say this is the list. Now this is the original, right? I wanna create a clone, which means I will create 1 and somehow I put 2 and 4. Now I can't copy 2 from here because this is the original. So I need to create 2, then I will add it here. And then I need to create 4, and then I add it here. So with the BFS, the idea is like, okay, you give me 1, you give me the root 1. What I'm gonna do is I'm gonna add it to the queue, and then I'm gonna append or create 1 here, the old node, and add the value of it, the new node. I'm gonna create new node and I'm gonna give it the value 1. Now I have a copy of it. But this one is like not reference. This is a new. So we're gonna do like, we're gonna call node and we're gonna give it a value, the same value that it have. And it's gonna have a neighbor, which is a list. In this case, it's gonna be empty. It's gonna be empty, right? Now we're gonna add 2 and 4 to the queue, and then we're gonna add to the queue before or after. I forgot. When we do BFS, do we do after or before? I think before. No, I think it's same, because we're gonna just keep adding. Okay, let's think about it. Let's create the queue. Here's the queue. We add 1. Then we're gonna pop it. Okay, so we have while queue, so that's the main loop that's gonna keep looping. We pop the element, and when we pop the elements, we gonna we're gonna add it So we need to add it to the queue. Okay, let me reset. Okay, take it slowly and we're gonna solve it. So we add 1, then we to the queue, then while queue we enter the loop, we pop it. Let me write it here so we can stay focused. So while queue we pop element from queue. Okay, now we pop it and we will need to add this element to the visited, which is a hash table. Okay,
I guess you make the clone first based on the popped item or element, and then in the hash table you put both the element and the clone, and then I guess a for loop that goes through the neighbors and just appends them to the...
Okay, so for loop, so let's say in the start we're gonna put this directly inside the root. We're gonna put it directly inside here. So the hash table gonna work like the old node, and the key gonna be the value as new node. So 1 gonna be equal 1 and the list gonna be empty because I can't add 2 and 4 here because I don't have 2 and 4, right? I guess like Sabah said, we're gonna loop on the for loop for each neighbor. For each neighbor, now that we pop 1, imagine it's right here, and it have neighbor 2 and 4, because what is the goal now? I want to add 2 and 4 here, but I want to add them from here, so I need to create them so I can make a new node of them, 2 and 4, which is gonna be the second part. Which is gonna be here for each neighbor. We're gonna check if this neighbor exists in the visited, right? Check if neighbor exists in visited, which this hash node right here. If it exists, let's say if it doesn't. If it doesn't exist, that mean we're gonna need to add it. So I'm gonna add 2. Where is it? This is the old node, right? And then inside the key of it, I'm gonna create a new node and I'm gonna give it the same value, which is 2. And of course, empty list. Because 2, so 1, 2, 3, 4. 2 have 1 and 3 as a neighbor, and I only have 1. I don't have 3 yet. So we're gonna do, if it doesn't exist, we're gonna create it. Where is it? Append, or like add to visit it. How to write it in a way we can understand, because so add to visited the element as key so this element as a key and the value, and the new node as the value of it. So the new node as the value of it. Okay, now if it exists, we can append this new value to here, which we're gonna do it anyway, right? So we can do append the clone, or let's use clone. So this is a clone to the neighbor clone. Okay, this is, I think, confused. Let me try put it simple. So we are processing one, right? We pop the elements from queue and we loop for each element. Now what we're looking for is we wanna add some value here. So what we did is we loop on the original 2 and 4 and we add them to here, which is here. Now that I added here, I can append it here, which I'm gonna append the value of it, which is a clone. So now I can put 2. Append the clone to the neighbor, which is this one. I can access the value and append it here. Okay, and if it was exist, directly I will append it. I don't have to go through this part if it doesn't exist. Let's loop again and see if it's gonna work. So we're gonna loop again. We're in this loop right here. So we're gonna loop again for each number, right? Now we did process 2, there's still 4. So 4. Check if the 4 exists and visit doesn't exist. If it doesn't exist, add it to visited the element as the key. So 4 as the key and the new node as the value of it. So this is the new node 4 empty list. But we did add 2 here, right? So here it's gonna be 2. But we're still missing 4, which gonna add it now. We did append 4, append the clone to the neighbor clone. So append the clone, this is the clone, to the neighbor clone, which is, this is the neighbor clone right here, neighbor 4. So we're gonna append it to here, 4. Now we did process this one. Okay, now that we process this, there is no more neighbor to add, but I think we're missing something, because if we finish here, the queue gonna be empty, the loop gonna stop. So each neighbor we process, we need to add it to the queue, so itself it don't stay empty. Notice here it is empty. So itself we need to add its neighbor. So here when we add to visited, we need also add it to the queue. So here we're gonna add element to the queue, or add element, or neighbor. Add neighbor to the queue. So if we add neighbor to the queue here, it's gonna be 2 and 4, right? 2 and 4. This one we did pop it, so it's gonna be out. Okay, let's try with 2 and 4 if it's gonna work. So that's it for the code, and then we're gonna loop. So this one did stop. Now the while loop gonna loop, and we're gonna take 2 out. We're gonna process it 2 and pop elements from queue. Here is it for each neighbor. So what neighbor this one have? it have, so this is the original, by the way, not the clone. It have it have 1 and 3, the original. Now check for each neighbor. So we're gonna loop for each neighbor. First time we're gonna loop on 1. Check if neighbor exists and visited. Is it exist? Yes, it is right here. Okay, so we create the clone. Need 2. So it's check if it exists. It doesn't exist, so we're not gonna enter here if it doesn't exist. So we're gonna go directly to the append link, right? So for each neighbor, check if the neighbor exists. Right, what am I writing here? Neighbor exists and visited. If it doesn't exist, in our case it exists, 1 exists, we're gonna append the clone to the neighbor clone. So we're gonna append the clone to the neighbor clone, wish 2. So this is our clone 2. So this is our clone right here. Append the clone to the neighbor clone. What I need to write here is it's a bit complex. Append the clone of this neighbor. Maybe this will make it better. To the clone of elements. So this 2 is elements, this is clone of neighbor. So this is neighbor, this is elements. So append the clone of the neighbor, which is 1 is neighbor, right? I can't put it directly, I need to append the clone of it. Now here is the directly one, the original. Here is the clone of it. So I will access it and take this value and put it here. This way I append the clone of the neighbor 1 to the clone of element 2. So basically I copy this one and I put it here. Okay, so this one gonna be here 1. Append the clone of this. Maybe with code gonna be more clear. This pseudocode is a bit messy. Okay, I hope it gets clear more and more. We're going through this example. So now we did finish this one. Now we have 1. We still need 2, right? We need 3 to append it here, right? And to remind you with the goal is like to copy all this graph and create a new node with the same neighbors and node. Now this gonna still loop the second time when we're gonna finish. Check if here this loop we have 2 loop for each neighbor. Now let's go to 3. It's gonna check if the 3 exists and visited. It doesn't exist, so it's gonna enter here. It's gonna add to the visited element as a key. Okay, 3, it's gonna be added here. Now what's gonna put in the value and the new node as the value of it. So here we're gonna create a new node and we're gonna give it a value 3 and empty list. Okay, now we created. Now we're gonna go to append it. Append the clone of this neighbor, which is 3, which is right here. So this neighbor appended to the element 2. So here 3. So I'm gonna copy this and paste it here. Now I have 3. Append the clone of this neighbor, which is 3, to the clone of the element 2. So we have 3, we have 2, and that's it. It's gonna finish. This loop gonna stop, and the while queue is still gonna loop because 4 is still here, and it's gonna be the same thing. 4 it have 2, 3, 4. It have 1 and 3 as neighbor. Now we need to process it. So here is the clone 4. It already exists, but it's empty. So it's gonna go for each neighbor, which is 1. If it already exists, just append it to the clone. Here is it already exists, so it's gonna append it to the clone, and it's gonna go to the next neighbor 3, and I think I missed something where before we needed neighbor to the queue. Did I miss something? I feel like I did miss something, but let's see. It's gonna show up. So 3, is it exist in the visited? It is. So it's gonna append it to here. Okay, so I did miss something, because here it should be 4 and 3. Why not? Oh no, the 3. Why 3 doesn't exist here? When I add it here, I did not add it. Oh, I forget to add it to the queue. Okay, so when I was processing 3 and it didn't exist, I added here, but I forget to add it to the queue. This line right here, add neighbor to the queue. So right now 4 have 1, 3 because they exist. But if I didn't add this 3 to the queue, I would not process this one, and I missed to add it when I was processing 2. When we were processing 2 and we say 1, it already exists, add it. When I go to 3 and I write it here, I should also add it to the queue here. I forgot to do that. So now we continue normally. We are in 4. 1, it already exists. Here is it. I'm gonna copy this. I'm gonna paste it here. 3, it already exists. Here is it. I'm gonna copy this. I'm gonna paste it here. Now we're gonna loop for each neighbor we finish. We're gonna loop queue because there's still 3. 3 also gonna happen the same, and probably 3 gonna be processed before 4. No, it did add it to the last, so it's same thing because we add 4 before 3. So let me remove this, and so we can do space for 3. Now 3, 1, 2, 3. Have 2 and 4. We're gonna do the same. We're gonna have 3, which is the new one. We're gonna pop it. Here is it. We pop it. Here is it. For each neighbor, we have 2. Check if the neighbor exists and visited. It exists, so I'm gonna copy this and paste it here. 2. Here is it. 2. If it doesn't exist, so for us it exists, so append it to the clone. So we did append it. We're gonna loop again. We have 4. 4, does it exist? Yes, it exists right here. I'm gonna append this to here. 4. And yeah, basically that's it. And then I will just return this what is it called? I will return the visited node, which is this one. Wait, which one I'm gonna return? I'm gonna return the root. Yeah, I'm gonna return the root of the clone. So we did create all this node, then I'm gonna return this one, and they are all connected, I guess. Yeah, because they are nodes, so they are all connected. Wait, is I missing something? We append the clone. No. Okay, I guess the logic here is working. It's just how we're gonna return. What we're gonna return. I guess we're gonna return. Should you keep the first clone? So I'm gonna access visited and do return clone, I guess. Return visited and what's one they give us here? This binary. They give us node. So visited node. So node is 1. Or yeah, 1. So we're gonna return 1. And 1 is connected with everything, so it's gonna work. Let's see, for example here. I still don't imagine it. Don't know, maybe I'm just tired. Because they are node and 1 is connected to 4. Okay, let's try to imagine it. So this is the new clone, right? Is 1 connected to neighbors 2 and 4. Okay, I see it now. And these 2 itself have neighbors, which are they're connected to 1 tree. And this 5 is have neighbors. Not 5, it's 4. 4 it have 1 tree. And this 3 have neighbor with 2. So each one have neighbor. So if I return this one, I actually like return everything because they are connected. So I just need to return the first one, the node one. Okay, let's code this one. By the way, who have question? Or if not clear something, please don't be shy. Don't be shy, just ask.
It's not clear for me, actually.
Okay.
Can you please?
Yeah, okay.
Explain.
Which parts not clear? Or everything not clear?
In the part where you add it to the queue over there, I can't.
This one?
Yeah.
So these parts?
No. I'm talking about the queue, like the diagram up, where you have 1.
This one.
2.
Oh, this one.
Yeah.
So you didn't understand why I have this 2, 4 here, right? For example, this part right here. You didn't understand this part?
Yes. Just quickly explain.
Okay, so our node is like the design of our node is like this. It's like, let's say this is our node. It have the value, which is can be 1, for example, and it have neighbors, which is a list. So in 1 we have 2. We have node 2 and node 4. Now this node 2 itself, it's like this. It have value 2, and it have neighbors, which is a list of 1 and 3, right? So by writing, for example, 1 to 4, I'm just like saying the value of this clone is 1 and the neighbor is 2, 4. You know what I mean? Is it clear?
Yes, it's clear.
So how we convert this to code? Let's try. Like this. So one of the solution I did to work on was DFS, which was something like this. I'm just gonna write the code in chat so we can like explain it after. I see Sabah also did DFS, I think. Okay, let's write the code, then we can see each other's solution after. So no. Okay, so reset. So while Q, where is it? While Q. But we said we're gonna add elements at the start. Wait, I feel like something missing here. Okay, so while Q, we're gonna pop elements, but before we do that, we will have to call the queue, right? So from collection, let me open the chat in case someone said something. From collection, import queue. Now we need to create this queue right here, so let's call it queue equal dq, and we're gonna put from the start the first node, right? So we're gonna put the node, which is node 1, from the start, and we're gonna add it to visited from the start. Visited. Now it's gonna be, the key is gonna be the node itself, the old one, right? So node, and the value of it is gonna be a new node, so we need to create a new node. Now we have this class node, we're gonna call it and give it value that we want, and because neighbor we don't have, we're gonna leave them empty like we did in the before, right? So let's just call it here node, and we're gonna give it node value. We can do like this, empty, but I think by default it's gonna be empty. So, but there's no default here. Value, we're gonna give it node value, so it's gonna have the same value. While queue, pop elements from the queue. So now we have like 1 inside, we're gonna pop it. Node queue pop left for, which is for each neighbor, we're gonna call it for neighbor. In what? For each neighbor, for the element that we pop. So the elements that we pop, so it was 1. When we pop it, it have neighbor. So node that we pop, node, and we can access it neighbor, which is a list, right? So neighbors, like saying loop on each neighbors. What we're gonna do to them, we're gonna check if neighbor exists and visited. So if neighbor wait, not exist, it doesn't exist, check if it doesn't exist. So we can do not in visited. If the neighbor doesn't exist and visited, then what we're gonna do, we're gonna add to visited the element as a key and the new node as the value. So how are we gonna do that? So we're gonna add the key, so visited, and so visited is the hash table, the key is the element, which is the neighbor, right? Neighbor. So if it was 1, so 2, we're gonna add 2 to the visited, which is her neighbor, and the value of it's gonna be a new node again, so a node, and we're gonna give it node value and then empty array because it doesn't exist, so we just add it. And after that we add neighbor to the queue. So queue append neighbor. Okay.
Sorry,
yes.
Nox.
Yes, bro.
I think that go back to the where you were. This line 19, I think it's supposed to be neighbor.value, not node.value. I'm not sure, but I think that's what it's supposed to be.
You're right, yeah, because we yeah, you're right, because node value doesn't exist. It's gonna, oh yes, because node value is actually gonna give us the value of 1, not the value of the neighbors. For example, 2, if I did node value, it's gonna give me 1. Neighbor value is gonna give me 2. So you are right, neighbor here. And then we're gonna add it to the queue. What else we said? Add it to the queue. And then we're gonna append. After F, we're gonna append the clone of this neighbor to the clone of the element. So basically we're gonna append the clone of 2 to 1, the clone of 1. Now the clone of 2, so we are gonna append the clone of 1, so this is the node, so visited node, right? Visited node, what's gonna happen? Is it visited the node? Append the clone of this neighbor.
I think what goodness is to put an else if statement, so that for if the neighbor exists in the visited, so we don't need to append it. All we needed to do is just to add what do you call it, a value and like neighbor node, that particular node that already existed in the visited. I don't know if you get what I'm trying to say.
I get, but I don't think we need to because let's say we create this neighbor, right? 2, right here, 2. Now we're gonna add the clone of 1 to here, 1. So it's gonna be like visited node, like this. When I'm gonna do visit node, I'm gonna access this value, and then I'm gonna access the neighbor of it, neighbor. neighbor.
So it should be visited neighbor, not visited node. Since you put the clone in visited neighbor.
But I'm accessing with the key, right? And the key is node.
Right, yeah.
And then, so I know this is a bit complicated. So basically I wanna, how do I access this part here? I'm gonna do visited to, and this 2 is the node, which is this one that we pop. And then I'm gonna do dot neighbors, which is dot neighbors. And then when I have access to this list, I'm gonna append what? I'm gonna append visited neighbor that I just created. Okay, let's do this one slowly, because I know it will be confusing to understand start. Or like let's do writers and then we do simulation of the code. So we append the clone of this neighbor to the clone of the element. So visited node neighbors append visited neighbor, and after that we're gonna keep going until we return visited node. Visited node, which is this one, which is the root, so the node 1, which is our connected. Let's see this code with simulation, let's see if it is makes sense. Okay, now let me remove this. Let me remove this. Okay, here's our code. Here's our graph. 1, 2, 3, 4, right? So we're gonna create Q, DQ node. So here's Q, DQ node. Our node at first is node 1. So 1. And 1 is have neither 2, 4, and 2 have neither 1, 3, and 3 have neither 2, 4, and 4 have neither 1, 3. So how do you know them? Is like you just see which one is connected. So 1 connected with 2, 4, 2 is connected with 1, 3, 3 is connected with 2, 4. Okay, we add this to the queue, and at the same time we add it to the visited. Let's do it something like this, so it's more clear. So visited, it's a hash table key and value. In the key we are putting old node, and the value is new node. Now we're gonna add the node, which is 1. This is old one, and the value of it is gonna be a new node which have 1 and empty list. So value 1, node value 1 and empty list. While Q have something, node pop. So here is pop, we pop it. Here is it. For neighbor in node neighbors. Now what is neighbor of this node is, we said 2 and 4. For the neighbor or node neighbors, so 2. If neighbor not in visited, which is not, right, we have only 1, we're gonna create visited neighbor. So in this case neighbor is 2, visited neighbor, here is it, we create the key, and we give it a value node neighbor value empty list. So neighbor value, which is 2 and empty list. Q append neighbor. Here is it. Q append neighbor. Visited node. Now visited node. What is the node? Node is this one. No. Right? This is the node that we pop. This is the neighbor. Now visited node, which is this. When you write visited node, it's gonna give you the value. So it's like visited 1. What is equal? Is equal 1 this. Now we're gonna access the visited node, which is this, dot neighbor, which is this array. Because remember, this is a node, right? And then we're gonna append to this array what? We're gonna append visited neighbor, which is this 2. What is visited neighbor? Visited of 2. Do we have it? Yes, here. What is the value? It is this node. So this node gonna be appended inside here. So this gonna have 2, right? And then we're gonna loop again 4 on the next neighbor, which is 4 again. It doesn't exist in visited, it's gonna create it. It's gonna have this 4 empty list, and seems it's gonna add it to the queue 4. And visited node, which is node is 1. Neighbor append visit neighbor, so it's gonna add 4, which is this. Visited node, which is 1. Visited 1, it's like visit 1. Go inside it and access the neighbor, which is this one right here. And append inside it visited neighbor. What is visited neighbor? Visited neighbor is 4, which is this value. So it's gonna append this inside here. And yeah, basically we're gonna loop like that. And we're gonna add it to the queue, add it here. Then with finish, we're gonna while queue again. The loop gonna go again. It's gonna pop the next element, which is 2. 2 have 1 tree, right? 2 have 1 tree, but 2, the clone that we have in visited, it's empty, right? So we need to copy this to here. Gonna do the same work. If the neighbor doesn't exist in visited, let's see, it exists in visited, so we don't need to create them. We just need to skip to this here, which gonna be visited node. Node is 2, visited of 2, which is this. Neighbor, which is this part. What we're gonna do to it, we're gonna append. What we can append? Visited neighbor. What's the neighbor we're looping for? Is 1. Because if for neighbor in node neighbor 1, it's light here, so we're gonna append this node to here 1. Then we're gonna loop again for next neighbor 3. Again, it's gonna do the same thing, but this time I'm gonna check if neighbor not in visit, it not. So it's gonna create it. It's gonna give it the value an empty list, like here, created with new node, appended to the queue 3. And the visited node, which is visited 2, right here, neighbor append visit neighbor 3, which is this. So it's gonna add 3 here. And we're gonna loop again the queue. This we did pop this too, so it's not there. Now this time I'm gonna pop 4. And 4 again, it have 1 tree. And what we're gonna do is for neighbor, so we're gonna loop on this one. Does it have, it already exists in this, so we're just gonna copy this to here. So this is gonna be 1. We're gonna loop on the next element. We're gonna copy tree, this one here, and that's it. We finish this loop, and the last loop with last element tree is 2 4. Have 2 4, right? Tree is connected to 2 and 4. Now our tree here is still empty, so we need to fix it. That's why we are doing this. So we pop it, we're gonna loop on 2 and 4. So first is 2, it exists, yes it exists, so we're gonna just access visited node, which is visited of tree, which is this value. We're gonna access dot neighbor, which is this part right here, the list, and we're gonna append to it. What we're gonna append? We're gonna append visited neighbor. Neighbor value is 2, so visited of 2 give us this value. So we're gonna copy this value right here. Here, forget to write 3. Copy this value 2 right here, so 2. And we're gonna go to the next element, which is 4. 4, it already exists, so we're gonna copy this value in here. So this is gonna be the for loop, and then the while queue gonna stop because there's no anything in queue, and we're gonna return the visited node, which is the head, which is the first element 1. So we're gonna return the visited 1 node, which gonna return this, which is the clone of the one, and this one is connected with all of them. So if we return this, we return all of them. Okay, now that's assuming the code work. Maybe it doesn't work. I think I did test this with BFS, but I'm not sure. The one I did was DFS. Let's run. What? Oh, DQ. Run. Visited. Run. You attempted to run code to zone. Please try again a few seconds. Okay, we can wait. No worry. Thank you for your service. Is that enough? Let's run again. Objet as attribute val. What? Node. Oh yes, forget this. Thank you. If not node, return. What do we return if not node? I guess none. We have, you must return the copy of the given node as the reference. Oh, node. What? That's what they mean. You must return the copy. Wait, is this not the copy? So what was the case? Okay, maybe I'm missing something here, but it did work in it. Oh, because it's empty. Okay, let's see. So, visited node val while queue. For neighbor in node neighbors, if neighbor not visited neighbor node, queue append neighbor visited node neighbors append visited neighbor. I'm gonna try something to remove this, see if it's gonna work. What is the problem? You must return a copy. Yeah, but it is a copy. If not, return not queue is DQ not. Not is not value. Then I do queue. I create DQ not. And while queue, I create not queue pop left. And then I go for neighbor in not neighbors. If neighbor not in visited neighbor equal not neighbor value. Okay, and then I add queue append neighbor, and then visited of the node access the neighbor, then append visited neighbor. Okay, let's print the visited. I am confused. What? No. Oh, because this is a DQ. Not that easy to... Okay, I don't know what's happened. I don't know. What could be wrong, guys? What could be wrong? Before we ask ChatGPT what's wrong in code. Because I think it should work. Okay. Did I do the devs? I did submit one, I think. Oh, I did not submit. Okay, but I did the devs. I don't think I did this one. But when we did it here, it did make sense. So why they are saying you must return a copy of the given as a ref node as the reference to the clone graph. Okay, let's use ChatGPT because my brain is tired. What's wrong with this code? And I couldn't see what's wrong. The issue with your code is that the find return visited node is outside of scope. Oh, what? Wait, what do you mean? Outside of scope? I think he's more sleepy than me. Therefore, when loop finished, node will hold the last node visit, which might not be the original. To fix, okay, so he did give us a hint. Let's try to fix this. What he's saying is this node can be holding the last node. Wait, I still didn't get it. But this node is inside the key. The usual code is that the final return statement return visit node is outside the scope of while. What? Okay, let's just go. I'm tired. I don't know what you mean. To fix this issue, you should return the clone version of the original starting node graph, which is stored in visited dictionary at the beginning. Wait, what's the difference? Are you joking with me? Return visited node neighbors. I don't understand why this work. Yours work, or did you copy the same one as mine at work? Did you change something? Clone value 1, clone node, clone value 1.
So basically I made the clone separately and gave it 1 since we know that's the beginning, and returned the clone instead of going to visit it directly.
Oh.
But I don't understand why it's different from what we just did.
Okay. Okay, let's see. Let's see what ChatGPT gave and compare and see. So visited node, neighbors, append, visited neighbors, queue append neighbor. What did he change?
I don't think he changed anything. It's the same.
What did you change, bro? Remove unnecessary imports, fix the indentation, change the return some return to clone version of the original. I don't get the last part. The original code final return statement visit node is outside the while loop. This means trying to return the last node visited in the loop might not necessarily be the original starting node of the graph. I changed the return statement visit node here visitor. Bro, you didn't change anything. What's wrong with you? What's wrong with you? Now, if you did clone, which is this one, node, it worked. If you did clone value, it worked later on. Oh, it worked. But how? So create clone. And then we put it here. And before it was what? Before it was node value. So node and then node value. So are you saying if I did like 1, it's gonna work? Why? Okay.
So I added a print statement at the end comparing clone with visited node, and they're not the same.
Oh.
I think what you're returning has a value of 3 for some reason.
This one is 3.
Yeah, but in the return.
Oh.
I don't understand as well, but
okay.
Maybe what GPT said might be half true, I guess.
Okay, but how the node change? It is the same?
I don't know.
Okay, let's print the node here. Node print node value. Run. Okay, it's print 1. Okay, what if I access visited node?
Print at the end too, before the return, so you see the difference.
Tree. So there is a mistake somewhere here. When I'm on 1, I change this value to 3. Now I can keep printing and see where it's gonna change. Okay, let's see. So visited node neighbor append visited neighbor. One. Oh.
I see the issue. You're overriding node inside the loop. No, even up. While Q, you're changing what node is, the original node. When you pop left.
Oh, the node. I need to give a different name. Oh yes, not X. Oh God. Thank you. Not X. So yeah, because we are using the same names, so yeah, it makes sense. ChatGPT, you could say that's better. Come on. Oh. Okay. Oh God. What's a PLD? Submit.
Remove the prints. I'll make it store.
Yeah. Okay. Oh, I forgot one. Okay, let's submit again. Oh, 19%. Wow. What? Maybe I should put that print again. Okay, that was a long PLD, guys. I hope no one sleep. I probably you guys sleep. Okay, we did learn too much, right? So that was the goal, I guess. So congratulations, we solved the 3 long LeetCode in the weeks. Yeah, what a night. So we did solve this week this one, we solved this one, we solved this one, this one, and tomorrow we're gonna solve this and this And yeah, if we survive to tomorrow, this gonna have it. And don't miss tomorrow's session. We have a genius guest that's gonna solve this for us, and they're gonna show us how the real way solve this code, not like me doing this here and there. Okay. They're probably laughing right now. Okay, so see you tomorrow, guys, same time, and hopefully we don't stay till 10 p.m. at night. Okay, see you tomorrow. Bye. Good night.
See you tomorrow.